Hello students, now today we will discuss emitter bias with the two supply. So already in previous biasing method we have already discussed there are four biasing methods like fixed bias, collector to base bias or feedback bias, emitter bias and voltage divider biasing. So out of four biasings, the voltage divider biasing is more suitable biasing methods than other biasing methods because of the Q points or your operating point is independent of the variation of the transistor parameters like leakage current and your beta and VB. So now today these examples we have to find out the emitter bias with the two supplies. Emitter bias with the two supply means what? If that is your here there are two supply. This is an emitter bias with the two supply. One is a plus VCC, another minus VEE. If there is two supplies given in the numericals, as far as your numericals, if there is two supplies, so how to calculate the DC current and DC voltages? In these examples, we have to calculate the DC current like base current IB, IC, VC, collector voltage, emitter voltage and collector emitter voltage VC. In these examples, so frequently the question asked in your different engineering service examinations or like public sector exam, if there are two supplies given, so how to calculate the DC current and DC voltages? In previous biasing methods only VCC is given, and here also there are two source voltage, one is your VCC and is your emitter supply voltage, one is collector supply voltage, another one is your emitter supply voltage. If two supply voltage are given, so how to calculate the DC current and DC voltages? Simply we have to apply the Kirchhoff's voltage law to the input and Kirchhoff's voltage law to the output, then find out the two equations and put the values, and you can find out the DC current and DC voltages here. One important thing is given also here, beta is given here, that is your 100. Okay, so solution. In this biasing method, emitter bias with the two supply, what will do? That is your what? Apply KVL to the input and apply Kirchhoff's voltage law to the output. Here there is an input loop here. Here minus VEE. Actually, how to form a loop here? Minus VEE means what? Already I told you, if you go from plus to minus, that is your minus. If you minus to plus, that is your plus. So as per your convenient, for your understanding, so I just make a loop so that it will easy for you. Here minus VEE, what you will do? That is there minus 10 volt. That is nothing but what? That is your, this is your plus terminal. This is your plus terminal and this is your minus terminal here like this, and we can say this is your 10 volt, 10. Plus to minus minus, in place of minus 10 I can make a loop here so that it is easy for you. You can apply Kirchhoff's voltage law like this. Okay. Similarly plus 10 volt here like this. In plus 10 volt means this is your plus terminal and this is your minus terminal, and you can make a loop here like this. Okay, then apply Kirchhoff's voltage law to the input and apply KVL to the output. First of all, apply KVL to input, apply Kirchhoff's voltage law to the input. What is my input equation? What is my input equation here? The current here, this terminal is connected to the base. Obviously the current is nothing but what? Base current IB here. Here that is nothing but a emitter current. This is your IE, emitter current here also, and this is nothing but your collector. This terminal is your collector terminal, and the current is nothing but your collector current IC. Okay. Then what will do? Apply KVL. If you go from plus to minus, then considering minus. If you go from minus to plus, that will be plus. Here the current here, the direction is like this, entering and plus, leaving and is minus. Here entering and plus, leaving and minus. And there is a potential, already I told you, in a transistor, this is your base terminal, this is your plate, this is your base, this is nothing but your base, and this is nothing but your emitter, and this is nothing but your collector. In between base and emitter there is a potential, that is your base emitter voltage, this is nothing but your plus and this is your minus, and this is nothing but a VB, base emitter voltage VB. So what we will do? If you apply KVL to the input, plus to minus minus, what is my input equation? Minus base current IB into RB. Here RB, we can say RB, the value of RB is nothing but 150 kilo ohm. IB into RB. Here plus to minus minus, that is your VB, that is your minus VB. Then plus to minus minus, that is your IE into RE, IE into RE. Then this voltage you should consider minus to plus, plus. This is your clockwise, the loop is clockwise, the current is flowing in clockwise direction. That's why what happened? Minus to plus is plus. You have to consider this voltage, that is your plus 10 volt, plus 10 equal to 0. First of all, we have to calculate the beta value is 100 is given. The first of all, what? Base current is what? We know that IC by IB equal to beta. IC by IB equal to beta. So IC equal to beta IB. IC equal to beta into IB. Here beta value is how much? 100. So IE, emitter current, IE equal what? IE equal to the base current plus collector current, IC plus IB. IC plus IB is nothing but what? 1 plus beta whole into IB. 1 plus beta whole into IB. What happened here? Minus IB, RB, 150. We can say just 150. 150 IB. Then minus VB, if VB value is not given, consider VB equal to 0.7. That is your minus 0.7. Minus IE, IE is nothing but, if you apply KVL to the input, whatever the current, if collector current is given, make converted into base current, IC equal to beta IB. If emitter current IE is given, IE equal to 1 plus beta times IB. So we have converted this equation in terms of IB so that the IB value can be determined. So minus IE here what? 1 plus beta whole into IB into RE. RE value is how much here? RE is your 1 into 1 plus 10 equal to 0. So that is your here the term containing here IB also, here the term containing IB, and another two terms here, that is minus 0.7 and plus 7. Go to the right hand side, it becomes, if it is minus, it will be plus, and plus it becomes minus. So minus 150 IB minus 1 plus beta. 1 beta is nothing but 100. 1 plus 100 into IB equal to how much? That is your minus 10 plus 0.7. 10 RHS become negative, minus 10 plus 7. And if IB taking common, minus IB taking common, what is the value here? That is your 150 plus 100 plus 1, that is your 101. RE value is 1, that's why 1 into multiplied to anything, that will be same value. 150 plus this one into IB equal to minus 9.3. Or IB equal to how much? Minus will be cancelled out. Or IB equal to, base current IB equal to, that is your 9.3 divided by, that is your 150, that it becomes 1, and this is nothing but what? 251. The IB, what is the value of IB? The value of IB, if using calculator, that is your 9.3 divided by 251. The value is your what? 0.037. The value is your 0.037 what? Milliampere, because I have not mentioned in your kilo ampere. This is your kilo. Denominator side is 251 kilo ohm, and 1 by kilo is nothing but milli. Milli is nothing but 10 to the power minus 3. And IB value is your what? Here IB equal to your IB equal to 0.037 milliampere, or we may say the base current can be expressed as microampere. So that's your micro means again in 3 digit, that is your 37. You can write 37 microampere. IB is nothing but what? 37 microampere here. Okay. After getting IB, you can immediately convert it into emitter current, because IE value is how much? IE equal to 1 plus beta times IB, 1 plus beta whole into IB. So beta value is 100, 100 plus 1, 101, 101 into that is your 0.037. That value is how much? That is your 101, 101, 101 into that is your 0.037. The value is your 3.737. 3.737 milliampere. Okay. The IE emitter current equal to here, IE equal to 3.737 milliampere. Okay. So this is nothing but your IE. Then what will do? This is, if you apply KVL, you will get the input equation. From this input equation, converted IB, I emitter current into 1 plus beta times IB. All value has already been given. So then put the values and you can find out the base current IB equal to 337 microampere or 0.037 milliampere. Once you get IB, then immediately convert it into emitter current, because emitter current equal to 1 plus beta times base current. 1 plus beta is given 100, 100 plus 1, it is nothing but 101 into 0.037. Why I am choosing this one? Because emitter current must be converted into milliampere. So here IB expressed in milliampere, here IB expressed in microampere. If the question asked find the value of IB, you should be mentioned IB equal to in terms of microampere. So we need IE in terms of milliampere, that's why I am taking IB equal to 0.037 milliampere. Simply 1 plus beta, 1 plus 100, that is 101 into 0.037, the value will come, that is 3.737 milliampere. It is nothing but your emitter current. Then apply KVL to the output. Then apply KVL to the output. If you apply KVL to the output, apply KVL, Kirchhoff's voltage law, to output. To the output. What is my output equation? Look at this here. 10 volt. This is nothing but 10. Okay. Here I am anticlockwise. The current flowing in anticlockwise in this loop. If you move from plus to minus, consider minus. If you from minus to plus, that will be plus. Minus to plus, plus. That is your 10. Again here, this is your plus and this is your minus. That means what? The 10, again you reach here resistance. If there is a resistance, multiplied with the current. This terminal is connected to the collector. That's why the current is nothing but collector current. IC into 3.5. Then plus to minus, minus. There is between collector and emitter, there is always potential VCE. Already I told you, it is not given. You have to take into account. You have to consider. If there is a base and emitter, there is between base emitter voltage VB. In between collector and emitter, there is a collector emitter voltage VCE. So if you apply KVL, here minus to plus, plus 10 volt, here plus to minus, minus. Current is what? Since it is a collector terminal, the current is your collector current. IC, that is your 3.5 into IC, then plus to minus, minus, minus VCE, then plus to minus, minus IE into 1, that is your IE, again that is your minus to plus, plus, that is your 10, plus 10 equal to 0. If you not apply properly KVL both input and output, your entire calculation will be wrong. If there is a resistance, multiply with the current. If there is a voltage, consider that voltage. If you move from plus to minus, that is your minus. If you move from minus to plus, that will be plus. So that's why if there is how many number of potential here in this loop? 1 and 2. That's why 2 loop here. How many number of resistance here? There are 2 resistance. Two resistance means there is 2 drops. One drop here, another drop is here. I into RE. And BC you should consider, because in between collector to emitter there is a potential collector emitter voltage. You should carefully, if you apply KVL to the input or output loop, carefully you should write the equations. Then what will do? If there is a collector current, you know, here IB equal what? Collector current. IC equal beta IB, or IC, what? IC equal to IB by IC equal to beta IB. IC equal to beta IB. IB is how much? IB equal to 0.037. That is your 100 into 0.037. And it is around what? 3.7 milliampere. IB is your 3.7 milliampere. So that's why this is your 10 minus 3.5 into that is your 3.7. Always remember, and this your IC is your milliampere, millimeter 10 to the minus 3, and 3.5 is your kilo ohm, 10 to the power plus 3. 10 to the power plus 3 into 10 to the power minus 3, it will becomes 1. So that is 3.5 into 10 to the power plus 3 and 3.7 into 10 to the power minus 3. It is same, only multiplied 3.5 into 3.7. Then VCE is unknown here, VCE. Then minus IE, already IE, we calculate I equal to 3.737, 3.737. Because I is a million, I into RE, RE is 1, that's why I have not mentioned here, I into 1. I into 1 means 1 kilo ohm. Kilo milli, that will be cancelled out, only minus 3.737 plus 10 equal to 0. What is my value here? That is your 10 plus 10, that is your 20 minus 3.5 into 3.7, 3.5. So 3.5 into 3.7, the value will be how much? 12.95 minus 12.95 minus VC, which is unknown, minus that is your 3.737, 3.737 equal to 0. So VC value is how much here? So VCE equal to so 20 goes to the right hand side, it becomes negative minus 20. Here minus 12 become right hand side, that will be plus 12.95, and minus 3737 becomes positive to the go to the right hand side, plus 3.737. The value will be how much here? 12.95, then plus 3.737, that is your 16 point this. So minus 20, then minus 20. The value will be your what? That is your minus 3.313. Therefore, VC value is your, that will be equal to how much here? That is your minus 3.313. Here VC value is your minus 3.313. Here VC, we got VCE equal to one of the operating point, that is come around minus 3.313 volt, 313 volt. It is nothing but your what? VCE. Then what we will do? Then we will calculate the VC. VC and VE. What is VC? This is nothing but your VC. And this is nothing but your what? That is your VE. VC is nothing but, from this to this is nothing but VC. This voltage from this to this is nothing but VC. Otherwise, this minus this is nothing but VC. So how to calculate VC? So VC value, how to calculate VC? So VC is nothing but collector potential VC equal to, that is your this voltage plus this one plus this one. So VC is nothing but this voltage. Look at this. This is nothing but VC. What is VC? This voltage plus this drop plus this is nothing but VC. Otherwise, total voltage minus this drop. Total minus this drop is nothing but VC. VC means collector potential. So VC equal to, if we move from plus to minus, that is your minus 10 here. Then here minus to plus, plus I into RE, I into 1, IE into 1. Then minus to plus plus VCE. This is nothing but VC. So which is equal to minus 10 plus IE. IE is nothing but what? 3.737. 3.737 milli kilo cancel out. 1 is kilo ohm. This is milliampere plus VC. Already VC is nothing but what? Minus 3.313. What will be my value? That is nothing but, it is around minus 13.313 plus 3.737. So minus 13.3.313 13.313 minus, that is your 3.737, that is your, and it is becomes what, minus, this is minus and this will be plus, minus 9.576, and Vc, collector potential Vc equal to your minus 9.576. Then how to calculate V? This is your Vc. Then VE, emitter voltage. VE is how to calculate VE. V is nothing but this one, plus to minus minus 10. That is your minus 10, minus 10, minus 10 plus this drop, plus IE into RE, IE into RE. That is your minus 10 plus IE is nothing but what? IE is your 3.737, 3.737 into RE is nothing but 1. And the value is how much? That is your 10 minus 3.737, 6.263. That is your V is nothing but minus, this is your minus 10, this plus, that is your minus 6.263 volt. This is nothing but your VE, emitter potential. So in this way we can calculate all the DC current and DC voltages. Okay. This is your VE and this is your VCE, this is your IE and this is your VC, all the DC current and DC voltage. In this way we can evaluate it or calculate it. So thank you. Again we will do more and more number of examples for different types of problems related to DC biasing of a BJT. Thank you.